Hello, I welcome you all to this another interesting screencast where we're going to be solving this engineering mechanics problem, and it reads determine the product of inertia of the shaded area with respect to the x and the y axis. This problem is coming from the engineering mechanics statics textbook 13th edition by R.C. Hibbeler. So product of inertia of an area is also a geometric property, just like moment of inertia of an area, but this one is mainly used for determining the maximum and minimum moments of inertia over an area. These maximum and minimum values of area moment of inertia are important properties needed for designing structural and mechanical members or elements such as beams, columns, and shafts. Mathematically, product of inertia of an area with respect to the x and y axis is defined as I sub xy equal to integral of xy dA. Okay, and if we are using the parallel axis theorem, you have I sub xy equal to I x c y c. This is a product of inertia of an area about the centroidal axis plus dx dy times area. All right. And units of measurements for this are also units of length to the power 4. And for product of inertia, you can have a negative, product of inertia, you can have a positive product of inertia, you can also have a zero product of inertia. The zero product of inertia happens, or it takes place when either x or y axis is an axis of symmetry. Okay, so when you have asymmetry in your area that you're dealing with, either about the x-axis or the y-axis or both, then you expect product of inertia of an area about with respect to x and y-axis is going to be equal to 0. Okay, so I think this is about it. Let me wrap this stuff here so that we dive into this problem. So let's cut a strip. I think we can cut a strip somewhere there. Not too good enough. Let's cut a very strip, something like so. Okay, all right, so this is going to be our dx. It's cutting the curve at this point. This point here is our x comma y, and then we have this height, this whole height equal to this height here. So assume this line is straight, this is y, and then you have this value there which is equal to x, and then the centroidal location of this small strip, this one is y curled is equal to y divided by 2. Okay, so now then we know that our dA is going to be equal to the height, which is y, times the thickness, which is dx. All right, and then we have the equation y squared governing this area equal to 1 minus 0.5x. So let's write this product of inertia in differential form. So we'll have dixy equals to dixcyc plus dx dy dA. Okay, so let's integrate on both sides. But we know that because this strip is symmetrical at y over 2, there is symmetry. So we expect this to be equal to 0. Okay. So product of inertia over data is equal to 0 when x or y axis, okay, when x or y axis is an axis of symmetry, right? So we just remain with the 2. So let's write that. So that becomes just xy equal to, and then we know that, let me just write something here. We know that our dx is just equal to x, and our dy is equal to y cubed, which is equal to y over 2. So our xy is going to be equal to integral of x, then our dy is just y over 2, and then our dA, what's our dA? Our dA is y. This is our dA here. Okay, this is our dA. This one is our dA. Okay, we are feeding it there. Okay, it is y dx. So if we to simplify this becomes equal to, integrating along the x-axis is from 0 to 2, then x y squared divided by 2, then dx. Then ixy is going to be equal to integral from 0 to 2, y squared, let's replace this value here, this value, and replace this value here. Okay, and once we do so, then we're going to have x, y squared is 1 minus 0.5 x, okay, divided by 2 dx. All right, so let's evaluate that. Let's evaluate that. Let me draw this line properly. Okay, something like that. Great. Let's evaluate that. Then our ixy is going to be equal to, we can factor out a half outside, then we'll have integrating from 0 to 2, then we have x minus 0.5 x squared dx. Integrating that, then we have a half x squared divided by 2 minus 0.5 x to the power 3 divided by 3. Okay, right? Then we are evaluating this from 0 to 2. And if we did our evaluation, grab your calculator, you're going to have 2 squared, that's 4 divided by 2, minus 0.5 by 2 to the power 3 divided by 3, and then times half, or divided by 2. Okay, so that becomes 0.333. Okay, so moment of inertia, a product of inertia of an area is going to be equal to 0.333 meters to the power 4. Okay, yeah, I think this is about it. And I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.